So now we're going to talk about addition and subtraction when it comes to fractions. So remember, when you add or subtract fractions, you have to have a common denominator. And before you even simplify, you actually subtract first. So 7 minus 5 is 2. And then you keep the denominator the same. And then you always simplify at the end, which is a little different than what we've done on the others. So 2 6 would simplify down to 1/3 because they're both divisible by 2. Now, if there's not a common denominator, what you do is you find your least common multiple or the least common denominator of each fraction. So if we have a 3 and a 4, our least common denominator would be 12. Our LCD is 12. That's because it's the smallest multiple that goes into both 3 and 4. So in order to change this, we always have to multiply each fraction by a 1. So in order to get this 3 to be 12, we have to multiply by a 4. So I'm going to multiply by 4 over 4. And then on this side, I'm going to multiply by 3 over 3. So that will give me 4/12 plus 3/12. And now I can add, and it'll be over 12. So 4 plus 3 is 7. And that does not simplify. So let's apply that to these problems. I'm going to switch this actually to an addition problem, because I think the next two are subtraction. So, actually, no, I lied. We're gonna keep it. I forgot. I'll switch one of the others. Okay, so what we're gonna do in this one, since the denominators are exactly the same, I can go ahead and subtract. Here's my biggest suggestion. A lot of people mess up on their subtraction because they forget this negative sign applies to both terms right here. So I always suggest switching the sign, so switching that to addition and then distributing a negative into each term. So that's now a negative x, and this is now a positive 1. So then I combine like terms. 2x plus a negative x is just a positive x. And then we've got plus 1 over x squared minus 1. Now remember, addition, subtraction is different than the others. You actually are going to simplify at the very end. And if possible, sometimes it doesn't simplify, but this one does, because x squared minus 1 is a difference of perfect squares. And so I can factor as x minus 1, x plus 1, and then you'll notice you've got a common factor of x plus 1 on the numerator and denominator. And since there's nothing left over on the numerator, I put a 1, because technically you're multiplying by 1, and then put that over x minus 1, and we are done. Let's see another one. So I'll switch this one to addition. It's not going to make a big difference. So for this problem, the denominators are not the same. So what we're going to do is find the least common denominator. And the easiest way to do that is to actually factor each denominator. So, and notice I'm only going to factor denominators. So we're going to factor these. The first one doesn't factor, so I'm going to keep it exactly as is. The second one does factor. It's a difference of perfect squares. So it factors. And then notice how they already have a common factor of x plus 3. So what am I going to end up doing so they get the exact same denominator is I'm going to multiply the first fraction by x minus 3 over x minus 3. Because remember, it has to be 1. So that x minus 3 over x minus 3 is 1. But then I have the missing factor in there. That way both of them will have the same two factors on the denominator. So that will give me 2x. Now I am going to be distributing the numerator because eventually we have to add them. So I'm going to go 2x squared minus 6x over x minus 3x plus 3. I don't typically factor or distribute the denominator just because if we have to simplify at the end, I like to keep it in factored form. But you do what you want. But for sure distribute the numerator because we're going to have to combine like terms up here. So we get 2x squared, negative 6x plus x is negative 5x plus 1. Now at this point, before I even write this next part down, if you don't like it written out as x plus 3x minus 3, if you can tell that this right here is not going to factor, and it doesn't factor down more, then if you like everything to just be in standard form, you could write it out as x squared minus 9. And you could have in this step too. You don't have to write it as x plus 3x minus 3. Either way, just make sure it's simplified, everything's factored down, or all common factors are taken out, and so on. And that's your answer. Let's see another one. I'll keep this one subtraction. I am going to switch this, because I like to do this when I keep it as subtraction. I like to switch it to a plus and then just distribute the negative to the numerator. So for this problem, in order for this to work, we're going to have to get a common denominator, and they're not common. Biggest mistake is people will think, oh, well, I'll just subtract 2 from the top and bottom, or subtract 6 in this case, from the top and bottom, and then you'll get x minus 6, or 2, because 4 minus 6 is 2, negative 2. The issue with that is that whenever you change the denominator, you have to be multiplying by something that's equal to 1. So, like, I could multiply by negative 6 over negative 6, but you guys want to add or subtract negative 6, and that's not going to work. So, moral of the story is always factor these first. If they have nothing in common, no factors in common, I should specify that, then just multiply each one by each other. So on this side, we're going to multiply this side by x minus 2. And on the other side, we'll multiply by x plus 4. Over x plus 4, I should say. And then once again, like I said on the previous problem, I always distribute the numerator, but I don't necessarily distribute the denominator, but you are very welcome to do so if that is what you like to do. This is negative x squared plus 2x over x plus 4, x minus 2. That's negative x squared plus 4x plus 8 over x plus 4, x minus 2. Quick way to see if this actually factors as a trinomial, multiply those together, and then see if there are any factors of negative 8 that add up to 4. The answer is there are not any. Therefore, this right here is your answer.